Azure Directory Services form the backbone of identity and access management in the cloud environment. At the heart of this service is Microsoft Entra ID, a robust cloud-based solution that revolutionizes how organizations manage user identities and access control. Microsoft Entra ID serves as a gateway, enabling seamless access to a wide array of Microsoft Cloud applications. This integration streamlines user experience, allowing for single sign-on capabilities across multiple platforms and services. Beyond Microsoft's offerings, Entra ID extends its functionality to support custom cloud applications developed by your organization, providing a unified identity solution for all your cloud-based needs. One of the key strengths of Microsoft Entra ID lies in its ability to bridge the gap between cloud and on-premises environments. By integrating with your existing on-premises Active Directory, it creates a hybrid identity solution. This integration allows for a smooth transition to cloud services while maintaining the familiarity and control of your traditional Active Directory setup. Microsoft Entra ID serves a diverse range of users, each with unique needs and responsibilities within the digital ecosystem. IT administrators leverage Entra ID to maintain tight control over access to applications and resources, aligning these permissions with their organization's specific requirements. This granular control enables them to enforce security policies effectively and manage user access efficiently. For app developers, Microsoft Entra ID opens up a world of possibilities. It provides a standards-based approach to enhance the functionality of their applications. Developers can seamlessly integrate features like single sign-on (SSO), allowing users to access multiple applications with a single set of credentials. Moreover, they can design their apps to work with existing user credentials, streamlining the user experience and reducing friction in adoption. End users benefit from the self-service capabilities of Microsoft Entra ID. They can manage their own identities, performing tasks such as resetting passwords without IT intervention. This self-service approach not only empowers users but also reduces the workload on IT support teams. Lastly, subscribers to Microsoft's suite of online services, including Microsoft 365, Office 365, Azure, and Dynamics CRM Online, are already utilizing Microsoft Entra ID. It serves as the authentication backbone for these services, providing a unified identity solution across Microsoft's cloud ecosystem. Microsoft Entra ID offers a comprehensive set of services designed to secure and streamline identity and access management. At its core, Entra ID provides robust authentication services. This includes verifying user identities for accessing applications and resources, as well as offering advanced features like self-service password reset, multi-factor authentication, and smart lockout services to enhance security. Single sign-on (SSO) is another key functionality of Microsoft Entra ID. SSO allows users to access multiple applications with just one set of credentials, significantly simplifying the user experience. This not only improves productivity but also enhances security by reducing the number of passwords users need to remember and manage. Application management in Microsoft Entra ID extends to both cloud and on-premises applications. Features like Application Proxy enable secure remote access to on-premises web applications, while integration with SaaS apps and the My Apps portal provides a unified access point for users. Device management is an integral part of Microsoft Entra ID's offerings. It supports device registration, allowing organizations to manage devices through tools like Microsoft Intune. This capability enables the implementation of device-based conditional access policies, restricting access attempts to those coming from known and compliant devices, regardless of the user account requesting access. In the evolving landscape of IT infrastructure, Many organizations find themselves straddling both on-premises and cloud environments. This hybrid scenario often leads to the challenge of maintaining two separate identity sets, one for the on-premises Active Directory and another for Microsoft Entra ID in the cloud. However, Microsoft has developed a solution to bridge this gap and create a unified identity experience. Enter Microsoft Entra Connect, a powerful tool designed to synchronize user identities between your on-premises Active Directory and Microsoft Entra ID. This synchronization is not a one-time event, but a continuous process, ensuring that changes in either system are reflected in the other. The result is a consistent identity experience that spans both your on-premises and cloud environments. The benefits of this integration extend beyond mere synchronization. With Microsoft Entra Connect, you can leverage advanced features like single sign-on, SSO, multi-factor authentication, and self-service password reset across both systems. This means users can enjoy a seamless experience, accessing both on-premises and cloud resources with the same credentials, while IT administrators can enforce consistent security policies across the entire infrastructure. Microsoft Entra Domain Services represents a significant leap forward in the realm of managed domain services. This service provides essential domain functionalities such as domain join, group policy, LDAP, and Kerberos NTLM authentication, all without the need for you to deploy, manage, or patch domain controllers in the cloud. It's akin to having the robust capabilities of Active Directory domain services, but as a managed service in the Azure cloud. One of the key advantages of Microsoft Entra Domain Services is its ability to support legacy applications in the cloud. Many organizations face challenges when moving legacy applications that depend on traditional authentication methods to the cloud. Microsoft Entra Domain Services provides a solution by allowing you to lift and shift these applications into a managed domain environment, eliminating the need to maintain and manage an ADDS infrastructure in the cloud. Integration is another strong suit of Microsoft Entra Domain Services. It seamlessly integrates with your existing Microsoft Entra tenant, allowing users to sign into services and applications connected to the managed domain using their existing credentials. This integration extends to groups and user accounts as well, which can be used to secure access to resources in the managed domain. This cohesive approach significantly smooths the transition of on-premises resources to Azure, reducing complexity and improving user experience. Microsoft Entra Domain Services represents a significant leap forward in the realm of managed domain services. This service provides essential domain functionalities such as domain join, group policy, LDAP, and Kerberos NTLM authentication, all without the need for you to deploy, manage, or patch domain controllers in the cloud. It's akin to having the robust capabilities of Active Directory domain services, but as a managed service in the Azure cloud. One of the key advantages of Microsoft Entra Domain Services is its ability to support legacy applications in the cloud. Many organizations face challenges when moving legacy applications that depend on traditional authentication methods to the cloud. Microsoft Entra Domain Services provides a solution by allowing you to lift and shift these applications into a managed domain environment, eliminating the need to maintain and manage an ADDS infrastructure in the cloud. Integration is another strong suit of Microsoft Entra Domain Services. It seamlessly integrates with your existing Microsoft Entra tenant, allowing users to sign into services and applications connected to the managed domain using their existing credentials. This integration extends to groups and user accounts as well, which can be used to secure access to resources in the managed domain. This cohesive approach significantly smooths the transition of on-premises resources to Azure, reducing complexity and improving user experience. This diagram illustrates the integration between on-premises Active Directory and Microsoft's cloud-based identity services, with a focus on the role of Entra Connect. Let's break down the key components and their relationships. On-premises environment, left side, Active Directory Domain Services. This represents your traditional on-premises identity management system, which many organizations have been using for years to manage user identities and access. Azure Cloud Environment, right side, Microsoft Entra ID, formerly Azure AD. This is Microsoft's cloud-based identity and access management service. It serves as the central hub for managing identities in the cloud environment. Microsoft Entra Domain Services, located below Entra ID. This managed service provides domain services in the cloud without the need to deploy, manage, or patch domain controllers. Entra Connect Center. This crucial component, now simply labeled as Entra Connect, bridges the on-premises and cloud environments. It facilitates identity synchronization between the on-premises Active Directory and Microsoft Entra ID. The arrows in the diagram represent the flow of information. The bidirectional arrow between on-premises AD and Microsoft Entra ID indicates two-way synchronization via Entra Connect. This ensures that identity information remains consistent across both environments, allowing for a unified identity experience. The downward arrow from Microsoft Entra ID to Microsoft Entra Domain Services shows the one-way synchronization of identity information to the cloud-based domain services. This architecture offers several key benefits. Unified identity. Users can access both on-premises and cloud resources using the same credentials, simplifying the user experience. Seamless integration. On-premises AD and cloud services work together harmoniously, providing a smooth transition path to cloud services. Simplified management. Administrators can manage identities and enforce security policies consistently across the entire infrastructure, both on-premises and in the cloud. Legacy application support. Microsoft Entra Domain Services enables organizations to lift and shift legacy applications to the cloud that require traditional Active Directory features, without the need to maintain domain controllers in the cloud. In the realm of Azure security, authentication plays a pivotal role in safeguarding your digital assets. It's the process that verifies the identity of users, services, or devices attempting to access your Azure resources. Think of it as a digital bouncer, carefully checking IDs before granting entry to your cloud environment. Azure offers a diverse array of authentication methods, each designed to balance security and user convenience. Let's explore these methods. Standard passwords, while familiar, represent the most basic form of authentication. They're like the simple locks on your front door, functional but not impenetrable. Azure supports this traditional method, but it's often combined with other techniques for enhanced security. Single sign-on, or SSO, streamlines the user experience by allowing access to multiple applications with just one set of credentials. It's akin to having a master key that opens various doors in your office building. SSO not only boosts convenience, but also improves security by reducing the number of passwords users need to remember and manage. Multi-factor authentication, commonly known as MFA, adds layers of security to the authentication process. It's like having a lock on your door, plus a security system. MFA typically combines something you know, like a password, something you have, like a mobile device, and something you are, like a fingerprint. This multi-layered approach significantly enhances your Azure environment security posture. Passwordless authentication represents the cutting edge of identity verification. It eliminates the need for traditional passwords, instead relying on more secure and user-friendly methods like biometrics or security keys. It's comparable to advanced smart home systems that recognize you automatically. This method not only bolsters security but also dramatically improves the user experience. Single sign-on, commonly known as SSO, is a game-changing authentication method in the world of Azure and beyond. At its core, SSO is about simplicity and efficiency. It allows a user to sign in just once and then use that single set of credentials to access a multitude of resources and applications, even if they're from different providers. Imagine having a master key that opens not just your house, but your car, office, and gym locker too. That's essentially what SSO does in the digital realm. It's a powerful tool that addresses several key challenges in identity and access management. First and foremost, SSO tackles the problem of password fatigue. In today's digital landscape, users often juggle dozens of accounts, each with its own password. This leads to poor password habits, such as using weak, easily guessable passwords or reusing the same password across multiple accounts. SSO eliminates this issue by reducing the number of passwords a user needs to remember to just one. From an organizational perspective, SSO is a boon for IT departments. It significantly reduces the strain on help desks, cutting down on password-related issues like account lockouts and reset requests. When an employee leaves the company, IT no longer needs to track down and disable multiple accounts across various systems. With SSO, disabling a single account effectively revokes access to all connected resources. SSO also enhances security in several ways. By reducing the number of credentials in circulation, it narrows the attack surface for potential breaches. Users are more likely to create and remember one strong, complex password than multiple ones. Moreover, SSO often integrates seamlessly with other security measures like multi-factor authentication, further bolstering your defenses. However, it's crucial to note that SSO is only as secure as its initial authentication process. Think of it as a castle gate. Once someone's through, they have access to everything inside. This underscores the importance of implementing strong initial authentication methods and combining SSO with other security measures. In the Azure ecosystem, SSO is a key component of a robust identity and access management strategy. It works hand in hand with Azure Active Directory, allowing for seamless, secure access to both cloud and on-premises applications. By leveraging SSO, organizations can create a more user-friendly environment while simultaneously enhancing their security posture. Multi-factor authentication, commonly referred to as MFA, is a cornerstone of modern security practices in Azure and beyond. It's a method that significantly enhances the security of user authentication by requiring multiple forms of verification before granting access. To understand MFA, let's break it down into its components. In essence, MFA asks users to provide two or more pieces of evidence, or factors, to prove their identity. These factors fall into three main categories. Something you know. This is typically a piece of information that only the user should know, such as a password or a PIN. It's the most traditional form of authentication, but also the most vulnerable if used alone. Something you have. This factor involves a physical object in the user's possession, like a smartphone, a security token, or a smart card. For example, when you receive a code via SMS to complete your login, you're using this type of factor. Something you are. This relates to biometric characteristics unique to the user. It could be a fingerprint, a facial recognition scan, or even a retina scan. This factor is becoming increasingly common with the proliferation of biometric sensors in smartphones and other devices. The power of MFA lies in its layered approach to security. By requiring multiple factors, it creates a much more robust defense against unauthorized access. Even if an attacker manages to compromise one factor, say by obtaining a user's password, they would still need to overcome the additional factors to gain access. In practice, MFA might look something like this. After entering your username and password on a login page, you're prompted to enter a code sent to your phone or to approve the login via an authenticator app. This process ensures that even if someone has stolen your password, they can't access your account without also having access to your phone. The benefits of MFA are substantial. It dramatically reduces the risk of identity theft, data breaches, and other cyber attacks. For businesses, it helps protect sensitive information and can be a crucial component in meeting various compliance requirements. For individual users, it provides peace of mind, knowing that their digital identities are protected by more than just a password. In the Azure ecosystem, MFA is deeply integrated and highly customizable. Azure Active Directory supports various forms of MFA, allowing organizations to choose the methods that best fit their security needs and user preferences. This could include SMS codes, phone calls, mobile app notifications, or even biometric factors. However, it's important to note that while MFA significantly enhances security, it's not infallible. The security community continuously works on improving MFA methods to stay ahead of evolving threats. For instance, there's a growing preference for app-based authenticators over SMS-based ones, as SMS can potentially be intercepted. Microsoft Entra Multi-Factor Authentication, MFA, and passwordless authentication represent cutting-edge approaches to identity verification. Let's delve into these technologies and understand how they're reshaping the way we think about authentication in Azure environments. Microsoft Entra Multi-Factor Authentication is Microsoft's robust MFA service seamlessly integrated into the Azure ecosystem. It enhances security by requiring users to provide additional forms of verification beyond just a password. When enabled, users might be prompted to respond to a phone call, enter a code received via SMS, or approve a notification in a mobile app. This additional layer of security significantly reduces the risk of unauthorized access, even if a user's password is compromised. The beauty of Microsoft Entra MFA lies in its flexibility and user-friendliness. Organizations can choose which additional factors to employ based on their security needs and user preferences. This customization ensures that security is enhanced without unduly burdening users or hindering productivity. While MFA significantly bolsters security, the tech world is moving towards an even more secure and user-friendly approach. Passwordless authentication. This innovative method aims to eliminate passwords altogether, replacing them with more secure and convenient alternatives. Passwordless authentication in Azure revolves around the principle of combining something you have, like a registered device, with something you are, biometrics, or something you know, a PIN. This approach not only enhances security, but also dramatically improves the user experience by eliminating the need to remember and manage complex passwords. Azure offers three main options for passwordless authentication. Windows Hello for Business. This is ideal for organizations where employees have dedicated Windows PCs. It leverages the built-in biometric sensors, like fingerprint readers or facial recognition cameras, or a PIN to authenticate users. Windows Hello for Business ties the authentication directly to the device, providing a seamless and secure experience for accessing both local and cloud resources. Microsoft Authenticator app. This mobile app turns any iOS or Android phone into a strong, passwordless credential. Users can sign in to any platform or browser by getting a notification to their phone, matching a number displayed on the screen to the one on their phone, and then using their biometric, touch or face, or PIN to confirm. FIDO2 security keys. These are external security keys that support the fast identity online. FIDO, Open Authentication Standard. They can take various forms, including USB devices, Bluetooth devices, or NFC-capable devices. Users can carry these keys with them and use them to authenticate across devices, applications, and services. As we delve deeper into the concept passwordless authentication in Azure, two methods stand out for their effectiveness and user-friendliness: the Microsoft Authenticator app and FIDO2 security keys. Let's explore these innovative approaches that are reshaping how we think about identity verification in the digital age. The Microsoft Authenticator app represents a significant leap forward in mobile-based authentication. This tool transforms any iOS or Android smartphone into a powerful passwordless credential. It's designed to offer a seamless and secure authentication experience across various platforms and browsers. Here's how the Authenticator app works in a passwordless scenario. When a user attempts to sign in, they receive a notification on their phone. The user is then presented with a number on their computer screen and asked to match it with the number displayed on their phone. This step prevents phishing attacks by ensuring the user is responding to a legitimate sign-in attempt. Once the numbers are matched, the user confirms their identity using their phone's biometric capabilities, such as fingerprint or facial recognition, or by entering a PIN. This process eliminates the need for passwords entirely, replacing them with a combination of something the user has, their phone, and something they are, biometrics, or no, PIN. The result is a highly secure yet user-friendly authentication method that significantly reduces the risk of credential theft. Moving from mobile to hardware-based solutions, we have FIDO2 security keys. FIDO2 is the latest standard developed by the FIDO, Fast Identity Online Alliance, an organization dedicated to reducing the world's over-reliance on passwords. FIDO2 security keys are physical devices that serve as unphishable credentials for authentication. They can come in various forms: USB devices that plug directly into a computer, Bluetooth-enabled devices for wireless authentication, NFC-capable devices for tap-and-go authentication. Some platforms even have FIDO2 compliant keys built directly into the hardware. The beauty of FIDO2 lies in its standardization and versatility. Because it's an open standard, it allows for interoperability across different platforms and services. This means a single FIDO2 key could potentially be used to access a wide range of services, from your Azure work account to personal online banking. When using a FIDO2 key for authentication, the user inserts or taps their security key when prompted during sign-in. The key performs a cryptographic challenge response with the service to prove the user's identity. In many cases, the user may need to perform an additional action, like pressing a button on the key or entering a PIN, to complete the authentication. This method is highly secure because the cryptographic keys never leave the secure hardware of the FIDO2 device. Even if a service provider's servers were compromised, an attacker couldn't steal anything that would allow them to impersonate the user. Both the Microsoft Authenticator app and FIDO2 security keys offer significant advantages over traditional password-based authentication. Enhanced security. By eliminating passwords, they remove the primary target of many cyber attacks. Phishing, password spraying, and credential stuffing attacks become ineffective. Improved user experience. Users no longer need to remember complex passwords or go through frequent password resets. Reduced IT costs. Password-related help desk calls and resets are significantly reduced. Compliance. These methods can help organizations meet stringent regulatory requirements for access control. Azure External Identities represent a powerful solution for managing interactions with users outside your organization. This concept is crucial for businesses looking to expand their digital ecosystems and collaborate efficiently with external partners. At its core, Azure External Identities allow you to securely interact with users who are not part of your immediate organizational structure. This capability opens up a world of possibilities for collaboration with partners, distributors, suppliers, and vendors. By leveraging Azure External Identities, you can share your resources and define access parameters for your internal users to connect with external organizations. For developers working on consumer-facing applications, Azure External Identities provide a robust framework for managing customer identity experiences. This feature ensures that you can create seamless, secure, and user-friendly authentication processes for your end users. One of the most innovative aspects of Azure External Identities is the Bring Your Own Identity concept. This approach allows external users to utilize their existing credentials, whether they're from a corporate, government, or social identity provider. For instance, users can sign in using their Google or Facebook accounts, streamlining the authentication process and reducing friction. By supporting various identity types, Azure External Identities cater to a diverse range of users and scenarios. Whether you're dealing with corporate partners who have their own identity systems, government entities with specific security requirements, or individual consumers using social media accounts, Azure External Identities can accommodate these varied needs. It's important to note that while external users bring their own identities, the security of your resources remains under your control. The external user's identity provider manages their identity, but you retain control over access to your apps through Microsoft Entra ID or Azure AD B2C. This separation of concerns ensures that you can maintain robust security measures while still offering flexibility to your external users. The revised diagram presents a streamlined view of how Azure External Identities work, focusing on the core components and the basic flow of authentication and access. At the heart of this system is Azure AD B2C External ID Management, represented by the central wide rectangle. This comprehensive service is split into two key concepts: Azure AD B2C, the core platform that handles identity and access management; External ID Management, the specific functionality tailored for managing external user identities. This service acts as the bridge between external users and your applications, managing the entire process of external identity verification and access control. On the left, we have the external user. This could be a customer, partner, or any individual outside your organization who needs to access your resources. The external user initiates the process by attempting to authenticate. The first arrow, labeled Authenticate, shows the user's credentials being verified by Azure AD B2C External ID Management. This step is crucial as it allows users to log in with their preferred identity, whether it's a social account, corporate credentials, or any other supported identity provider. Once authentication is successful, we move to the second arrow, labeled Access. This represents Azure AD B2C granting the authenticated user appropriate access to your app, shown on the right side of the diagram. Your app could be any resource within your organization, a web application, mobile app, or API that you want to make accessible to external users in a controlled manner. This simplified flow illustrates the key benefit of Azure External Identities. It provides a secure, centralized way to manage external user access to your resources. By leveraging Azure AD B2C External ID Management, you can offer flexible authentication options to your external users, centralize identity management for enhanced security, implement consistent access policies across your applications, scale your identity solution as your user base grows. Azure External Identities offer a comprehensive suite of capabilities designed to facilitate secure and efficient collaboration with users outside your organization. Let's delve into each of these capabilities. Business to business B2B. Collaboration. This feature is the cornerstone of external collaboration in Azure. It allows external users to access your Microsoft applications and other enterprise applications using their preferred identities. This means partners, vendors, or clients can use their existing work, school, or social accounts to sign in, eliminating the need for creating new credentials. In your directory, these users are typically represented as guest users, allowing for easy management and oversight. B2B Direct Connect. This is a more advanced feature that establishes a mutual two-way trust between your Microsoft Entra organization and another. The current primary use case for B2B Direct Connect is team shared channels. This feature enables external users to access your resources directly from their own team's environment, creating a seamless collaboration experience. Unlike B2B collaboration, these users aren't represented in your directory, but they are visible within the team's shared channel and can be monitored through Teams Admin Center reports. Azure Active Directory Business to Customer, B2C. While B2B focuses on business users, B2C is designed for consumer-facing scenarios. It allows you to publish modern SaaS apps or custom-developed applications to consumers and customers. Azure AD B2C handles all aspects of identity and access management for these consumer-facing apps, providing a secure and scalable solution for managing customer identities. These capabilities aren't mutually exclusive. Depending on your specific needs, you can use a combination of these features to create a comprehensive external identity strategy. Microsoft Entra ID makes it easy to enable collaboration across organizational boundaries using the Microsoft Entra B2B feature. Administrators can invite guest users from other tenants, and in many cases this invitation capability can be extended to regular users as well. This flexibility extends to social identities like Microsoft accounts, further broadening your collaboration options. An important aspect of managing external identities is ensuring appropriate access levels. Microsoft Entra ID provides robust tools for this purpose, including access reviews. You can initiate reviews where either the guests themselves or designated decision makers participate in recertifying or attesting to the guest's access needs. These reviews are supported by intelligent suggestions from Microsoft Entra ID, helping reviewers make informed decisions about continued access requirements. Once an access review is completed, you can easily implement changes, including removing access for guests who no longer require it. Azure Conditional Access is a powerful tool within Microsoft Entra ID that significantly enhances an organization's security posture while maintaining user productivity. Let's delve into its key aspects and functionality. What is conditional access? Conditional access acts as a gatekeeper for your organization's resources. It makes real-time decisions about allowing or denying access based on a variety of signals. These signals include who the user is, their identity, where the user is located, their geographical location, what device the user is using to request access. The primary goals of conditional access are twofold. Empower users to be productive from anywhere, at any time. Protect the organization's assets from unauthorized access and potential security threats. How conditional access works. The process of conditional access can be broken down into three main steps. Signal collection. During the sign-in process, conditional access gathers various signals. These could include the user's role in the organization, their IP address, indicating location, the type of device they're using, and the application they're trying to access. Decision-making. Based on these collected signals, conditional access makes a decision. This decision is guided by the policies set up by IT administrators. Enforcement. Finally, the decision is enforced. This could result in allowing access, denying access, allowing access, but requiring additional verification, like multi-factor authentication. A key feature of conditional access is its ability to provide a more granular and context-aware multi-factor authentication (MFA) experience. For instance, if a user is accessing from a known location using a managed device, they might not be challenged for a second authentication factor. However, if the same user tries to access from an unusual location or using an unrecognized device, they might be required to provide additional verification. When to use conditional access. Conditional access is particularly useful in several scenarios. Role-based MFA, requiring multi-factor authentication based on a user's role. For example, you might always require MFA for administrators, but only sometimes for regular users. Location-based access control. Implementing different access requirements based on a user's location. For instance, you might have stricter controls for access attempts from outside your corporate network. Application control. Limiting access to services only through approved client applications. This helps prevent access from potentially unsecured or unmonitored applications. Device management, requiring users to access applications only from managed devices. This ensures that accessing devices meet your security and compliance standards. Blocking suspicious access, preventing access from untrusted sources such as unknown or unexpected locations. By leveraging conditional access, organizations can implement a zero-trust security model. Azure Role-Based Access Control, commonly known as Azure AD, is a crucial component in managing access to resources within the Azure cloud environment. This powerful system allows organizations to implement the principle of least privilege effectively, ensuring that users and services have only the permissions necessary to perform their required tasks. At its core, Azure RBAC addresses a fundamental challenge in IT management: how to maintain security while efficiently managing access for multiple teams and individuals. Instead of painstakingly defining and updating access requirements for each user, Azure RBAC enables administrators to assign users to roles, which come with predefined sets of permissions. Microsoft provides a comprehensive set of built-in roles that cover common access scenarios in Azure. These roles range from broad, like owner or contributor, to highly specific, such as virtual machine contributor. Each role is associated with a collection of permissions that dictate what actions can be performed on which resources. For organizations with unique requirements, Azure RBAC offers the flexibility to create custom roles. This feature allows you to define precisely the permissions needed for specific job functions within your organization, maintaining the balance between access and security. One of the key benefits of Azure RBAC is its ability to simplify access management at scale. When you add a new team member, you can simply assign them to the appropriate role, and they immediately inherit all the necessary permissions. Similarly, when new resources are added to your Azure environment, existing role assignments automatically apply, ensuring consistent access control across your expanding cloud infrastructure. Azure Role-Based Access Control, RBAC, is a powerful system for managing access to resources within the Azure environment. The key to understanding how RBAC works lies in grasping the concept of scope. In Azure, scope refers to the set of resources to which access permissions apply. Azure AD operates on a hierarchical model with 4 levels of scope. Management groups. These sit at the top of the hierarchy and represent collections of multiple subscriptions. They're often used to organize resources for large enterprises or companies with complex structures. 2 subscriptions. The next level down, subscriptions are the basic unit of Azure services. They're tied to an Azure account and form the billing boundary for resource usage. 3 resource groups. Within subscriptions, resource groups act as containers for related resources. They're often used to group resources that share a common life cycle or belong to the same application. 4 individual resources. At the most granular level, you can apply RBAC directly to specific resources like virtual machines, storage accounts, or databases. The hierarchical nature of Azure RBAC is one of its most powerful features. When you assign a role at a parent scope, those permissions are automatically inherited by all child scopes. For example, if you grant someone the owner role at the subscription level, they'll have full control over all resource groups and resources within that subscription. This inheritance model allows for efficient and consistent access management. However, it's important to note that more specific assignments at lower levels can override broader permissions from higher levels, allowing for fine-grained control when necessary. Different roles can be assigned to different scopes based on the needs of your organization. For instance, A senior IT administrator might be assigned the owner role at the management group or subscription level. A development team lead might be given the contributor role for a specific resource group containing their project's resources. A junior developer might be assigned a custom role with limited permissions on specific resources they're working on. An external auditor might be given the reader role at the subscription level to allow them to view but not modify any resources. By thoughtfully applying roles at appropriate scopes, you can ensure that each user or service has exactly the level of access they need, no more, no less, thereby maintaining security while enabling productivity. Azure Role-Based Access Control, RBAC, is a crucial component of Azure's security model, providing fine-grained access management for Azure resources. Understanding how Azure RBAC is enforced is key to effectively implementing and managing access control in your Azure environment. At the heart of Azure RBAC enforcement is Azure Resource Manager. This management service acts as the central point of control for organizing and securing your cloud resources. Azure RBAC is enforced on any action initiated against an Azure resource that passes through Azure Resource Manager. You can interact with Azure Resource Manager through various interfaces. Azure Portal, the web-based graphical user interface for managing Azure resources. Azure Cloud Shell, an interactive browser-accessible shell for managing Azure resources. Azure PowerShell, a task automation and configuration management framework. Azure CLI, command line interface, a cross-platform command line tool for managing Azure resources. When you attempt to perform an action on an Azure resource using any of these interfaces, Azure Resource Manager checks your permissions based on the roles assigned to you. If you have the necessary permissions, the action is allowed. If not, it's denied. It's important to note that Azure RBAC operates on an allow model. This means that when you're assigned a role, Azure RBAC allows you to perform all the actions specified within that role's scope. If you're assigned multiple roles, you effectively accumulate the permissions from all these roles. For example, if one role assignment grants you read permissions to a resource group and another grants you write permissions to the same resource group, you'll have both read and write permissions on that resource group. However, there's a crucial limitation to be aware of. Azure RBAC does not enforce access permissions at the application or data level. While it controls access to Azure resources and operations, it doesn't manage who can access specific data within an application or database. For instance, Azure RBAC can control who can manage a SQL database, but it doesn't control who can read or write data within that database. Application-level security must be handled separately by the application itself. This separation of concerns allows for a clear delineation between infrastructure-level access control, handled by Azure RBAC, and application-level access control, handled by the application. It provides flexibility for developers to implement security measures that are specific to their application's needs while still benefiting from Azure's robust infrastructure security. In practice, this means that a comprehensive security strategy for your Azure resources should combine Azure RBAC for resource-level access control with appropriate application-level security measures. This multi-layered approach ensures that you have control over who can manage your Azure resources, as well as who can access the data. The Zero Trust model represents a paradigm shift in cybersecurity strategy, moving away from traditional perimeter-based security approaches to a more comprehensive and adaptive framework. This model is designed to address the challenges of modern computing environments, which are characterized by cloud services, mobile workforces, and distributed data centers. At its core, the Zero Trust model operates on a simple yet powerful principle: trust nothing, verify everything. This approach assumes that a breach has already occurred and that no user, device, or network should be automatically trusted. regardless of their location or ownership. Microsoft, a leading proponent of the Zero Trust model, recommends 3 fundamental principles. Verify explicitly. This principle emphasizes the importance of authentication and authorization based on all available data points. In practice, this means authenticating and authorizing based on user identity, location, device health, service or workload, data classification, and anomalies. Using strong authentication methods like multi-factor authentication, MFA, for all users, whether they're inside or outside the organization's network, ensuring that authorization is dynamic and strictly enforced before access is granted. Use least privilege access. This principle aims to limit user access with just-in-time and just enough access, JIT, JEA, along with risk-based adaptive policies. Key aspects include limiting user access rights to only what is needed for their current task or role, implementing time-based and context-based risk policies to adapt access dynamically, using micro-segmentation to set precise controls over who can access specific resources. Assume breach. This principle operates on the assumption that a breach is inevitable or has likely already occurred. It involves minimizing blast radius for breaches and preventing lateral movement by segmenting access by network, user, devices, and application awareness. Verifying end-to-end encryption and using analytics to drive visibility, threat detection, and defense improvements. Implementing a comprehensive monitoring and alerting strategy to detect anomalous activity quickly. The Zero Trust model is particularly relevant in today's complex IT environments. With the rise of cloud computing, remote work, and bring your own device (BYOD) policies, the traditional security perimeter has become increasingly blurred. Zero Trust acknowledges this reality and provides a framework for securing resources regardless of where they're located or how they're accessed. Implementing Zero Trust is not a one-time project, but an ongoing journey. It requires a holistic approach that encompasses identity management, device health, application security, data protection, infrastructure, and networks. Organizations adopting Zero Trust often start by implementing strong identity solutions, then gradually extend Zero Trust principles across their entire digital estate. The shift from traditional security models to the Zero Trust model represents a fundamental change in how organizations approach cybersecurity. This transition is not just a technological shift, but a philosophical one that requires rethinking core assumptions about security. Traditional security model. In the traditional security model, organizations operated on the principle of trust but verify. This approach was based on several key assumptions. Network perimeter security. The corporate network was viewed as a safe haven. Firewalls and other perimeter defenses were expected to keep threats out, creating a hard-shell, soft-center security posture. Internal trust. Devices and users within the corporate network were generally trusted. Once inside the network, users often had broad access to resources. Managed devices. Only company-managed devices were typically allowed to join the network, with strict controls on personal devices. VPN for remote access. Remote access was tightly controlled through VPNs, which extended the trusted network to remote users. Static access policies. Access policies were often static and based primarily on network location rather than user identity or device status. Zero Trust model. The Zero Trust model flips these traditional assumptions on their head, operating on the principle of never trust, always verify. Key aspects of this new approach include assumed breach. Zero Trust assumes that breaches are inevitable or have already occurred. Every request is treated as if it originates from an uncontrolled network. Identity-centric. Instead of trusting devices based on their network location, Zero Trust requires everyone to authenticate. Access is granted based on authenticated identity and the security posture of the device. Least privilege access. Users are given the minimum levels of access needed to complete their tasks, reducing the potential damage from compromised accounts. Device diversity. Zero Trust supports a diverse range of devices, including personal devices, but requires verification of device health and compliance before granting access. Microsegmentation. Instead of a single, trusted network, resources are isolated, and access is segmented to minimize the blast radius of any potential breach. Continuous monitoring and validation. Trust is continuously evaluated. Changes in user behavior, device status, or network environment can trigger reauthentication or changes in access levels. Adjusting to zero trust. The transition to a zero trust model requires significant changes in technology, processes, and organizational culture. Identity and access management (IAM). Robust IAM systems become crucial with multi-factor authentication (MFA) as a standard practice. Device management. Organizations need to implement strong device management practices, including health checks and compliance monitoring for both corporate and personal devices. Network segmentation. Networks need to be re-architected with micro-segmentation in mind, isolating critical assets and limiting lateral movement. Continuous monitoring. Implementation of advanced threat detection and response capabilities becomes essential to detect and respond to anomalies in real time. Policy enforcement. Dynamic policy enforcement engines are needed to make real-time access decisions based on multiple factors. User education. Employees need to be educated about the new security model and their role in maintaining security. Application modernization. Applications may need to be updated or re-architected to support more granular access controls and integrate with zero trust systems. While the transition to zero trust can be complex and challenging, it provides a security model that is much better suited to modern, distributed IT environments. It offers improved security posture, better support for remote work and BYOD policies, and more granular control over access to critical resources. The diagram illustrates the key components and principles of the zero trust security model. Let's break down each element. Central policy engine. At the core of the diagram is the policy engine, represented by concentric circles. This symbolizes the central role of policy in the zero trust model. The policy engine is responsible for making real-time access decisions based on various inputs and predefined security policies. Key components. Surrounding the policy engine are 5 key components of the zero trust model. A. Devices represents all endpoints, including workstations, mobile devices, and IoT devices. B. Users symbolizes the human element, employees, contractors, and other users accessing resources. C. Applications represents both on-premises and cloud-based applications. D. Data symbolizes the organization's data, which is the primary asset to be protected. E. Network represents the network infrastructure, both internal and external. Connecting lines. The lines connecting each component to the policy engine represent the constant communication and verification processes. A verified device ensures that devices meet security standards before granting access. B. Authenticate user verifies the identity of users, often using multi-factor authentication. C. Authorize access grants or denies access to applications based on user identity and context. D. Encrypt data ensures that data is protected both in transit and at rest. E. Secure network implements network segmentation and monitors for threats. Continuous monitoring and validation. The outer dashed circle encompassing all components represents the continuous monitoring and validation process. This illustrates that in a zero trust model, Trust is never permanent. It's constantly re-evaluated based on changes in user behavior, device status, network environment, and other factors. Key principles. Illustrated: never trust, always verify. Every component is connected to the policy engine, showing that every access request is verified, regardless of its source. Least privilege access. The policy engine mediates all interactions, ensuring that users and devices have only the necessary level of access. Assume breach. The continuous monitoring circle illustrates the assumption that breaches may occur, necessitating constant vigilance. Identity-centric security. User authentication is a key component, emphasizing the shift from network-based to identity-based security. Micro-segmentation. The separation of components illustrates the principle of dividing the network into small, isolated segments. This diagram effectively captures the essence of the zero-trust model, a dynamic, identity-centric approach to security that continuously verifies every access request, regardless of its source or destination. It moves away from the traditional perimeter-based security model to one that acknowledges the complex, distributed nature of modern IT environments. Defense in depth is a comprehensive security strategy that employs a layered approach to protect an organization's information assets. The primary objective of this strategy is to safeguard sensitive data from unauthorized access and potential theft. By implementing multiple layers of security controls, Defense in Depth creates a robust security posture that can withstand and slow down various types of attacks. The concept of defense in depth can be visualized as a series of concentric circles, with the most valuable asset, the data, at the center. Each surrounding layer represents a different security control or mechanism, all working together to protect the core. This layered approach ensures that if one security measure fails, or is breached, other layers are in place to continue protecting the assets. Let's explore each layer of the defense in depth strategy, moving from the outermost to the innermost. Physical security. This is the outermost layer and the first line of defense. It involves protecting the physical infrastructure where data and systems reside. This includes measures such as secure data centers with controlled access security guards and surveillance systems, biometric access controls, environmental controls, fire suppression, temperature regulation, identity and access management. This layer controls who can access systems and data. It includes strong authentication mechanisms, multi-factor authentication, role-based access control, RBAC, regular access reviews and audits, privileged access management, perimeter security. This layer protects the network boundary and includes firewalls to filter incoming and outgoing traffic, intrusion detection and prevention systems, IDS, IPS, distributed denial of service, DDoS protection, virtual private networks, VPNs for secure remote access, network security. This layer focuses on securing the internal network. Network segmentation to limit lateral movement, internal firewalls and access controls. Network monitoring and traffic analysis, secure protocols and encryption for data in transit. Compute layer. This layer secures the systems and devices where data is processed. Endpoint protection, antivirus, anti-malware, host-based firewalls, regular patching and updates. Secure configuration, management application. Layer. This layer ensures that applications are secure. Secure coding practices. Regular security testing, e.g., penetration testing, code reviews. Web application firewalls, WAF, input validation and output encoding data layer. At the core, this layer protects the data itself. Data encryption, both at rest and in transit. Data loss prevention, DLP. Tools database. Activity monitoring, regular backups, and secure data disposal. The strength of the defense in depth strategy lies in its comprehensive and layered approach. Each layer provides a different set of security controls, making it increasingly difficult for an attacker to reach the core data. Azure provides a comprehensive set of security tools and features that align with the defense in-depth model, ensuring robust protection at every layer of your cloud infrastructure. Let's explore these security measures in detail. Physical security. Microsoft takes physical security very seriously in its Azure data centers. While customers don't have direct control over this layer, Microsoft implements strict physical access controls, including biometric scanning and multi-factor authentication for data center access, 24/7 video surveillance and security personnel, rigorous procedures for staff access, including background checks. Identity and access. Azure offers powerful tools to manage identities and control access. Azure Active Directory, Azure AD, a comprehensive identity and access management service, supports single sign-on, SSO, to thousands of cloud apps and services, provides multi-factor authentication for enhanced security. Azure AD Privileged Identity Management enables just-in-time privileged access with approval workflows and complete auditing. Azure AD Identity Protection uses adaptive machine learning algorithms to detect and prevent risk-based identity compromises. Perimeter. Azure provides robust perimeter defense capabilities. Azure DDoS Protection defends applications against distributed denial of service, DDoS attacks. Azure Firewall, a managed, cloud-based network security service that protects your Azure Virtual Network resources. Azure Front Door provides Web Application Firewall, WAF, protection for your globally distributed web applications. Network Azure offers various tools to secure network communications. Network Security Groups, NSGs, act as a firewall for Azure resources, controlling inbound and outbound traffic. Azure Private Link enables private connectivity to Azure PaaS services, keeping your traffic on the Microsoft network. Virtual Network Service Endpoints extend your virtual network private address space to Azure services, providing direct connectivity. Azure Bastion provides secure and seamless RDP SSH connectivity to your virtual machines directly from the Azure portal. Compute.Azure provides multiple layers of protection for compute resources. Azure Security Center offers unified security management and advanced threat protection across hybrid cloud workloads. Azure Update Management manages operating system updates for your Windows and Linux computers deployed in Azure, on-premises, or other cloud providers. Azure Disk Encryption encrypts Windows and Linux virtual machine disks. Microsoft Anti-Malware for Azure provides real-time protection against viruses, spyware, and other malicious software. Application. Azure supports building secure applications from the ground up. Azure App Service Authentication. Authorization provides easy-to-use authentication capabilities for web apps without changing code. Azure Key Vault safeguards cryptographic keys and secrets used by cloud applications and services. Azure DevOps includes security features in the development lifecycle, such as automated security testing and policy enforcement. Azure Application Gateway provides a web application firewall, WAF, to protect against common web vulnerabilities and exploits. Data. Azure offers comprehensive data protection services. Azure SQL Database Encryption provides encryption at rest for your database, associated backups, and transaction log files. Azure Storage Service Encryption automatically encrypts data prior to persisting it to Azure Storage and decrypts the data prior to retrieval. Azure Information Protection classifies labels and protects sensitive documents and emails. Azure Confidential Computing protects data while it's being processed in the cloud. By leveraging these Azure security tools and features across all layers of the defense in-depth model, organizations can create a robust, multi-layered security strategy. This comprehensive approach helps protect against a wide range of potential threats from physical breaches to sophisticated cyber attacks. It's important to note that while Azure provides these powerful security tools, proper configuration and management are crucial. Organizations should regularly review and update their security posture, conduct security assessments, and stay informed about the latest security features and best practices in Azure. Microsoft Defender for Cloud stands at the forefront of security posture management and threat protection in the ever-evolving landscape of cloud computing. This powerful monitoring tool is designed to keep a vigilant eye on your entire digital infrastructure, spanning cloud, on-premises, hybrid, and multi-cloud environments. At its core, Defender for Cloud serves as your organization's security sentinel, continuously assessing your systems and providing timely guidance and notifications. These insights are invaluable in strengthening your overall security posture, ensuring that your defenses are robust and up-to-date against the latest threats. One of the key strengths of Defender for Cloud lies in its comprehensive toolkit. It offers a range of features aimed at hardening your resources, effectively creating a more resilient infrastructure that can withstand potential cyber attacks. Moreover, it doesn't just focus on prevention. Defender for Cloud also equips you with the means to track your security posture over time, allowing you to identify trends and areas for improvement. In the fast-paced world of cybersecurity, efficiency is crucial. Recognizing this, Defender for Cloud has been designed to streamline security management. It consolidates various security tasks and processes, making it easier for teams to maintain a strong security stance without getting bogged down in complexity. A standout feature of Defender for Cloud is its seamless integration with Azure. For organizations already leveraging Azure services, deploying Defender for Cloud is a straightforward process thanks to its native integration. This ease of deployment ensures that you can quickly enhance your security measures without disrupting your existing operations. In essence, Microsoft Defender for Cloud offers a holistic approach to security, providing the tools and insights needed to protect your digital assets in today's complex, multifaceted IT environments. Microsoft Defender for Cloud sets itself apart with its comprehensive protection coverage, ensuring that your security posture remains robust across diverse computing environments. This wide-ranging protection is crucial in today's complex IT landscapes, where organizations often operate across multiple platforms and infrastructures. For Azure services, Defender for Cloud offers seamless native integration. This means that many Azure services are automatically monitored and protected without requiring any additional deployment steps. This native integration not only simplifies the security management process, but also ensures that your Azure resources are continuously protected with minimal effort on your part. However, Defender for Cloud's capabilities extend far beyond just Azure. Recognizing that many organizations maintain on-premises data centers, Defender for Cloud provides tools and features to monitor and protect these traditional infrastructures as well. This capability is particularly valuable for organizations in the midst of cloud migration or those maintaining hybrid environments for compliance or operational reasons. Speaking of hybrid environments, Defender for Cloud shines in its ability to provide unified security management across both cloud and on-premises resources. This hybrid protection ensures that there are no blind spots in your security posture, regardless of where your resources are hosted. In our increasingly multi-cloud world, Defender for Cloud steps up to the challenge by offering protection for resources hosted with other cloud providers. This multi-cloud support is achieved through the extension of Microsoft Defender plans to non-Azure machines with the help of Azure Arc. Additionally, Cloud Security Posture Management (CSPM) features are extended to multi-cloud machines without the need for any agents, further simplifying the process of securing diverse cloud environments. Microsoft Defender for Cloud offers a robust suite of Azure native protections designed to safeguard your cloud resources across various services and layers of your Azure infrastructure. These protections leverage Azure's deep integration capabilities to provide comprehensive security coverage. Starting with Azure Platform as a Service, PaaS offerings, Defender for Cloud casts a wide net of protection. It vigilantly monitors and detects threats targeting a range of Azure services, including Azure App Service, Azure SQL, and Azure Storage Account. This capability ensures that your cloud-native applications and data stores are continuously protected against emerging threats. A noteworthy feature in this realm is the integration with Microsoft Defender for Cloud Apps. This integration enables anomaly detection within your Azure activity logs, providing an additional layer of security by identifying unusual patterns or behaviors that could indicate a security threat. When it comes to Azure Data Services, Defender for Cloud goes beyond mere threat detection. It incorporates intelligent features that automatically classify your data in Azure SQL. This classification is crucial for maintaining proper data governance and ensuring compliance with various regulatory requirements. Furthermore, Defender for Cloud conducts comprehensive assessments to identify potential vulnerabilities across your Azure SQL and storage services. It doesn't stop at identification. It also provides actionable recommendations on how to mitigate these vulnerabilities, empowering you to proactively strengthen your data security posture. Network security is another critical area where Defender for Cloud shines. It offers sophisticated capabilities to limit your exposure to brute force attacks, a common threat vector in cloud environments. A standout feature in this regard is the just-in-time VM access. This feature allows you to harden your network by preventing unnecessary access to virtual machine ports. You can define secure access policies for selected ports, ensuring that only authorized users from allowed IP address ranges can access these ports, and only for a limited time. This granular control significantly reduces your attack surface while maintaining necessary access for legitimate users and processes. Many organizations operate in hybrid environments, combining on-premises infrastructure with cloud resources. Microsoft Defender for Cloud rises to this challenge by extending its robust security capabilities beyond Azure, encompassing your entire hybrid cloud environment. A standout feature of Defender for Cloud's hybrid protection is its ability to provide customized threat intelligence. This means that the security insights and recommendations you receive are tailored specifically to your unique environment. By understanding the intricacies of your infrastructure, Defender for Cloud can offer more relevant and actionable intelligence, helping you to focus your security efforts where they matter most. Complementing this customized intelligence is Defender for Cloud's ability to prioritize alerts based on your specific infrastructure. This prioritization is crucial in today's threat landscape, where security teams often face alert fatigue due to the sheer volume of potential issues. By contextualizing alerts within your environment, Defender for Cloud helps you quickly identify and address the most critical threats, enhancing your overall security posture. One of the key strengths of Defender for Cloud in hybrid environments is its ability to protect non-Azure servers. This means that your on-premises resources can benefit from the same level of advanced threat protection as your Azure resources. This unified approach to security helps eliminate blind spots and ensures consistent protection across your entire IT estate. Deploying these hybrid protections is made simple through Azure Arc. By leveraging Azure Arc, you can easily extend Defender for Cloud's enhanced security features to your on-premises machines. This seamless integration brings the power of cloud-native security tools to your traditional infrastructure, bridging the gap between on-premises and cloud security. In our increasingly diverse cloud landscape, many organizations find themselves leveraging multiple cloud providers to meet their specific needs. Microsoft Defender for Cloud rises to this challenge by extending its protective umbrella beyond Azure, offering robust security features for resources running on other major cloud platforms such as Amazon Web Services, AWS, and Google Cloud Platform, GCP. A prime example of this multi-cloud capability is Defender for Cloud's integration with AWS. When you connect an AWS account to your Azure subscription, you unlock a powerful suite of protection features. At the forefront is the extension of Defender for Cloud's Cloud Security Posture Management (CSPM) capabilities to your AWS resources. This agentless solution assesses your AWS resources against AWS-specific security recommendations, incorporating the results into your overall secure score. This approach ensures that your security posture is evaluated consistently across your multi-cloud environment. Compliance is a critical concern in any cloud environment, and Defender for Cloud addresses this by assessing your AWS resources against built-in standards specific to AWS. These include AWS CIS, AWS PCI DSS, and AWS Foundational Security Best Practices. This comprehensive compliance assessment helps you maintain a strong security posture while meeting industry-specific regulatory requirements. For organizations leveraging container technologies, Microsoft Defender for Containers extends its reach to Amazon EKS Linux clusters. This feature brings advanced threat detection and defense capabilities to your containerized workloads, ensuring that this critical component of modern cloud architectures is thoroughly protected. Defender for Cloud's multi-cloud protection doesn't stop at containers. Microsoft Defender for Servers brings its advanced threat detection and defense capabilities to both Windows and Linux EC2 instances in AWS. This ensures that your compute resources, regardless of the underlying operating system, benefit from the same level of protection across your multi-cloud environment. A particularly useful feature for organizations managing resources across multiple clouds is Defender for Cloud's Asset Inventory page. This multi-cloud enabled feature provides a centralized view of your AWS resources alongside your Azure resources. This unified visibility is crucial for maintaining a comprehensive understanding of your entire cloud estate, simplifying management, and ensuring no resources slip through the security net. Microsoft Defender for Cloud stands as a comprehensive security solution, addressing three critical needs in managing the security of resources and workloads across cloud and on-premises environments. This triad of capabilities, assess, secure, and defend, forms the cornerstone of a robust security strategy. The first pillar, continuous assessment, is all about maintaining constant vigilance over your security posture. Defender for Cloud provides tools and insights to help you understand your current security state, identifying vulnerabilities and tracking them over time. This ongoing assessment is crucial in the ever-evolving landscape of cybersecurity, ensuring that you're always aware of potential weak points in your defenses. Security, the second pillar, focuses on hardening your resources and services. Defender for Cloud leverages the Azure Security Benchmark, a set of guidelines and best practices specific to Azure environments. This benchmark serves as a foundation for implementing strong security measures across your entire infrastructure. By aligning with these standards, you can significantly enhance your overall security posture and reduce potential attack surfaces. The third pillar, defense, is where Defender for Cloud truly shines in its proactive approach to security. It goes beyond mere assessment and hardening by actively detecting and helping resolve threats to your resources, workloads, and services. This real-time threat protection is essential in today's fast-paced threat landscape, where quick detection and response can make the difference between a minor incident and a major breach. Together, these three capabilities create a comprehensive security lifecycle. Continuous assessment informs your security measures, which in turn strengthen your defenses. This cyclical process ensures that your security posture is not just strong at a single point in time, but continues to evolve and improve in response to new threats and vulnerabilities. Microsoft Defender for Cloud's continuously assess capability forms the foundation of a proactive security strategy. This feature ensures that you have an up-to-date, comprehensive view of your security posture across your entire digital estate. At the heart of this capability are Defender for Cloud's vulnerability assessment solutions. These tools cast a wide net, covering virtual machines, container registries, and SQL servers. This breadth of coverage is crucial in today's complex IT environments, where vulnerabilities can lurk in various components of your infrastructure. For server environments, Microsoft Defender for Cloud goes a step further by integrating seamlessly with Microsoft Defender for Endpoint. This integration is automatic and native, providing an additional layer of security intelligence. When enabled, this feature gives you access to the detailed vulnerability findings from Microsoft's Threat and Vulnerability Management System, enhancing your ability to identify and address potential security weaknesses. The assessment process in Defender for Cloud is not a one-time event, but a continuous activity. Regular detailed vulnerability scans are conducted across your compute, data, and infrastructure resources. These scans are designed to be thorough, identifying not just obvious vulnerabilities, but also subtle configuration issues that could potentially be exploited. One of the key strengths of Defender for Cloud's assessment capability is its centralized approach to reporting and remediation. All the results from these various scans and assessments are consolidated within the Defender for Cloud interface. This centralization allows you to review and respond to findings efficiently without having to switch between multiple tools or interfaces. The continuously assess capability doesn't just provide data, it offers actionable insights. By highlighting vulnerabilities and misconfigurations, it allows you to prioritize your security efforts effectively. You can focus on the most critical issues first, ensuring that your resources are protected against the most pressing threats. Moreover, this continuous assessment aligns perfectly with the dynamic nature of cloud and hybrid environments. As new resources are added or configurations change, Defender for Cloud's assessment capabilities ensure that these changes are quickly evaluated for potential security implications.